So if you notice, we've made no mention of time with any of our work or energy discussion. And you might wonder where time comes into this. So is it doesn't matter if you do a certain amount of work over a certain amount of time, less time or more time? Well, that's where power comes into play. So the word power in physics is simply stated, the time rate at which work is done. So power, P, is d work, d time. So you do the same amount of work pushing a box across the floor if you do it in 10 seconds as if you do it in 1 hour. You do the same amount of work, but you did a different amount of, you were exhibiting a different amount of power during that time between the two scenarios. So the quantity of power considers how quickly work is done. The SI unit of power is the watt. So the watt, I guess I started off earlier videos doing something like this for units. So capital W, which is a little bit confusing because capital W is the SI abbreviation unit for watt, but also we have here capital W for work. So try to keep those straight. 1 watt is equal to 1 joule, units of work, divided by 1 second, the SI unit for time. In other words, 1 watt is equal to 1 joule per second. The watt as a unit probably makes you think of electrical power, light bulbs, power grids, James Watt. But there's nothing inherently electrical about the watt. We can describe electrical things by their power. We can describe mechanical things by their power. Another unit that isn't the SI unit, but another unit for power is horsepower. So that's a unit of power. And you can describe a light bulb instead of 100 watts, you can describe it in a certain amount of horsepower if you want. It's just not very traditional, but it's perfectly valid. I don't have the conversion, so you can look it up if you're curious. And you can start telling your friends and family, yeah, I have a such and such horsepower light bulb, and so I get lots of light in my room. But anyways, we can express power in terms of force and velocity, and it's sometimes useful. So let me write this out well here. I'm going to box this in just to let you know it's worth remembering and jotting down in a nice place. And then here's another one I'm going to box in. Power is, of course, equal to dW dt. We can write that Fx delta x dt, or delta t. And so that would be F dot v. And that's a scalar product here. It's a dot product. F dot v. So that can be useful. It will probably come up. This concept of power, I don't think it requires too much more than stating. I think the concept of taking a time derivative of something is pretty clear at this point, going from position to velocity to acceleration and all the rest that you've probably covered in Calculus 1. So I'm going to leave it at that. But if it comes up in problems, you have these tools now to talk about power and the time derivative of work. All right, that's it for today. We're ending a little short, so you can use that time to catch up if you were trying to catch up on a previous lecture or chapter, or revisit something that you're unclear of, or just take it and remember it. And next time, sometime in the future, when I inevitably go over by 15 minutes, maybe you'll be a little bit more gracious for my going over your time. All right. Till next time.